Let us solve a couple of series problems. The first one is the series 1 plus 1 by 2 plus 1 by 2 times 3 by 4 plus 1 by 2 times 3 by 4 times 5 by 6 and so on. Now here the nth term will be 1 by 2 times 3 by 4 times 5 by 6 dot 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 2n minus 1 by 2n. Now this can be written in this form, product form. So product as k goes from 1 to n of 2k minus 1 by 2k. And this gets simplified to 1 minus 1 by 2k. So here this is the nth term of this series. When you verify this, you will notice that the first term 1 has been dropped from the series. And we can do that as we have seen before, that the initial finite terms can be dropped. Now, we don't want the product, we want summation. So how do we convert it? Remember, natural log of 2 times 3 is equal to natural log of 2 plus natural log of 3. So we are going to take the log on both sides. So natural log of u sub n is equal to the summation k equal to 1 to n of natural log of 1 minus 1 by 2k. We know that natural log of 1 minus x is less than or equal to minus x for x between 0 and 1. So applying it here, we get natural log of 1 minus 1 by 2k is less than or equal to minus 1 by 2k. Natural log of u sub n is equal to the summation k equal to 1 to n of natural log of 1 minus 1 by 2k. And this natural log of 1 minus 1 by 2k is less than or equal to minus 1 by 2k. Which means natural log of u sub n is less than or equal to minus 1 by 2 times the harmonic series. Now, we know that the harmonic series goes to infinity as n goes to infinity. That means it diverges, which implies natural log of u sub n, because of this minus, goes to minus infinity. We need to get rid of this natural log. So we exponentiate both sides. We get e to the power of natural log of u sub n going to e to the power of minus infinity. E to the power of minus infinity can be written as 1 by e to the power of infinity. And we know this is 0. So u sub n goes to 0 because e and natural log cancel, leaving u sub n. So that means the necessary condition is satisfied. Now let's do the ratio test or D'Alembert's test. So we need the ratio. So let's figure out u sub n plus 1. And that would be equal to 1 times 3 times 5 times up to 2n minus 1 is part of u sub n itself. That plus 1 will bring in another term, 2n plus 1. The whole thing divided by 2 times 4 times 6 times up to 2n, and then the next 2n plus 2. Now we take the ratio u sub n plus 1 by u sub n. Here we will be multiplying with the reciprocal. That means the even numbers and odd numbers will all get cancelled. And the only thing that will be left is 2n plus 1 by 2n plus 2. We take the limit. So limit as n goes to infinity of u sub n plus 1 by u sub n is equal to 2 by 2, which is equal to 1. And we know that the ratio of D'Alembert's test is inconclusive when the limit is equal to, limit of the ratio is equal to 1. So we can't say anything about convergence or divergence, which means this is where Raabe's test comes into picture. Remember Raabe's test? We need this expression and then we need to take the limit as n goes to infinity. So let's arrive at this expression. So we take the reciprocal of u sub n plus 1 by u sub n. We get u sub n by u sub n plus 1 is equal to 2n plus 2 divided by 2n plus 1. Then we subtract 1. So minus 1. Now simplify. And then we multiply both sides by n. When we simplify this, we get 2 minus 1, 1. Then we multiply n. So we get n by 2n plus 1. In the denominator, we refine it a little bit further by taking out n common out. So we have 2 plus 1 by n times n. N cancels out. Now we are in a position to take the limit. So when we take the limit, what happens is 1 by n goes to 0. And we are left with 1 by 2. So 1 by 2 is less than 1. And our Raabe's test says if the limit is less than 1, then the series is divergent. So we have reached our conclusion that the given series is divergent. Now let's look at the next problem. Series given is x plus 1 by 2 times x cubed by 3 plus 1 by 2 times 3 by 2, 4 times x to the power of 5 by 5 and so on. Now we have to figure out the nth term. So u sub n is equal to 1 times 3 times 5 times 7 times and so on up to 2n minus 1 divided by 2 times 4 times dot 2n times x to the power of 2n plus 1 divided by 2n plus 1. Now verifying the u sub n for n equal to 1, we see that it is 2 minus 1, that is 1 by 2 times x cubed by 3. That means what? The first term has been dropped. Now let's assume that the necessary condition is satisfied. Let's apply the ratio test, D'Alembert's test. For that we require u sub n plus 1. U sub n as it is, it will come plus 1 additional terms in the numerator and denominator. Not the terms, but basically factors. 2n plus 1 by 2n plus 2 times x to the power of 2n plus 3 by 2n plus 3. Okay, so now we have this. So taking the ratio u sub n plus 1 by u sub n, we get u sub n plus 1 divided by u sub n. Converting this to multiplication by taking the reciprocal and simplifying, we end up with 2n plus 1 by 2n plus 2 times x to the power of 2n plus 3 divided by 2n plus 3 times 2n plus 1 by x to the power of 2n plus 1. So basically here, when we take the reciprocal of this and make it a product, then the even numbers will cancel out and odd numbers will cancel out. Simplifying it further, we have x to the power of 2n plus 3 minus 2n minus 1. So we are left with x squared. 2n plus 1, 2n plus 1 becomes 2n plus 1 squared. And in the denominator, we have 2n plus 2, 2n plus 3. If we take the limit as n goes to infinity, what will happen? We will be left with x squared. And a quick way of figuring out this without actually carrying out the steps is to see that the numerator will have 4n squared. If we take out 2n out. And here again, 2n, we take it out, 2n, we take it out, we end up with 4n square. 4n square, 4n square cancel out. And we'll be left with, when we take the limit, 1 by 1 times x square, which is x square. If x square is less than 1 by D'Alembert's test or ratio test, the series is convergent. If it is greater than 1, then the series is divergent. But what happens when x square is equal to 1? Then the ratio test or D'Alembert's test is inconclusive. So now we have to figure out this part of the series. When x square is equal to 1, whether it converges or diverges. So now let x square be equal to 1 and continue with Raabe's test, which means x square in the ratio disappears. See, from here, if x square equal to 1, x square itself disappears. We don't have to consider it anymore. Do you remember? We have to convert what we have into this form. What we have is a ratio that we have to convert it into this form. So let's do that. So we have u sub n plus 1 by u sub n. But what we require is u sub n by u sub n plus 1. That is the reciprocal of this. So 2n plus 2 times 2n plus 3 divided by 2n plus 1 square. X square is equal to 1, so we can ignore it. Then we subtract 1 and then multiply it with n. We have to simplify the right hand side. So when we simplify this, we end up with 6n square plus 5n divided by 2n plus 1 square. We can do further simplifications by taking n square out and here 2n square out. Then taking the limit, we end up with limit as n goes to infinity of 6 plus 5 by n divided by 4 times 1 plus 1 by 2n the whole square. So here what has happened to that n square that we have taken out from both the denominator and the numerator? They get cancelled out. And now when we take the limit, 5 by n goes to 0, 1 by 2n goes to 0. So here we have 1 plus 0, that is 4 times 1 is 4. And here we have 6. 6 by 4 is 3 by 2, which is greater than 1. Remember, here if the limit of this expression is greater than 1, then the series is convergent. So our given series is convergent when x square is equal to 1. Make sure that you don't confuse this with the conditions of the ratio test, because there when it is greater than 1, the series is divergent. For different tests, there are different conditions. Anyhow, so that was Raabe's test. Now, if you found this session helpful, please do like, share, and subscribe. Comment suggestions are always welcome. Thanks for watching. See you in the next section. That's it for now.